On this week's MetPy Monday, we're going to talk about type hints, a relatively new feature in the Python language, and how it can make your functions and variables a little bit more transparent in what they're expecting and what their purpose is to yourself and other readers of your code. Welcome to another MetPy Monday. On this week's MetPy Monday, we're going to talk about a new feature of Python, which is type hinting. So you may be familiar with other languages such as C or C++ that are what we would call strongly typed. When you declare a variable, you have to declare a type with that variable, and that is the only type it can have, such as integer a equals 3. A cannot then be changed to a float or a string. It is an integer. So Python has this idea of duck typing and dynamic typing. If it looks like a duck, quacks like a duck, walks like a duck, it's a duck. So we can have a equals 3, and then a equals hello world as a string, and a equals 3.14, all one right after the other with no type specified. A just changes to accommodate the data that we have stored in it. This is really handy, but it can also make things kind of confusing if you have a function that takes some arguments and your user doesn't necessarily know what type of argument you're expecting. So you can use type hinting on actual just declaring, a equals 5, or you can use it in functions to indicate what each argument and the return type are going to be. So I'm going to show you an example of both of those today. And being a new feature, you're not going to see it in many codes that are out there. It's also not enforced in that you can say this should be a float, but Python will not throw an error if it doesn't. The type hints are purely for the users and developers of your code, not for the interpreter at all. So our task, our first one, is we're going to write a degrees Fahrenheit function that takes degrees Celsius and converts it to degrees Fahrenheit. Pretty simple task. So def degf, so I'm going to call my function. It takes degrees Celsius, and it's going to return degrees Celsius times 9 over 5 plus 32. So let's go ahead and test that function out. Degf. Now let's try 0 degrees Celsius. And let's try 100 degrees Celsius. So freezing and boiling. Those are 32 and 212 degrees respectively in Fahrenheit. So we know our function is working. But let's say I want to tell my user that this takes a float and returns a float. Though notice I've actually given it integers here. So again, it's not strictly enforced. I can put a colon, space, and then the data type. So that tells my user that this takes a float as an argument. And then I can make an arrow with a minus and a greater than symbol and specify my return type and move my colon to the end. So this is telling us that this function returns with the arrow a float, and then we have our colon and the actual function text. So there we go. It still works just as expected. If I shift tab to look at the docstring, we can see the function signature contains that information, which can be helpful to us as users. Though again, it doesn't necessarily enforce. So this is telling me it can't multiply because that's an invalid operation, not because I specified that it must be a float. So now let's go a little bit further with that and look at a function that uses an optional argument. So those of you familiar with Star Trek know that if a planet is classified as class M, it's suitable for human life. And I'm going to say that suitable for human life contains two things. The temperature has to be between 0 and 110 degrees Fahrenheit, which, yes, that's a pretty large range, but let's go with it. And the atmosphere must contain oxygen in it. And then we want to know, is this planet going to be classified as class M? So def is class M. It's going to take a temperature and the atmosphere. If the temperature is greater than or equal to 0 and the temperature is less than or equal to 110, so that means the temperature is fine. Now we're going to check atmosphere. If oxygen in atmosphere lowercase return true, else, actually we don't even need the else, we're just going to go return false outside of all of the ifs there. So if the temperature is fine, we'll go in here and see is oxygen in there or not. If it is, we'll return true. If neither of these are true, we're going to bounce out, or if this one's not true, and just return false. So we're going to return a Boolean, and this is just saying take whatever we get as atmosphere, make it a lowercase string, and if oxygen is anywhere in it, we're going to return true. Maybe not the greatest example because oxygen could be in a toxic atmosphere, but for this example, let's go with it. So I'm going to go ahead and use some type annotations on this. I'm going to make temperature a float. That makes sense. Atmosphere, I'm going to make it a string. I'm going to give it a default value of oxygen. So if we don't specify any atmosphere, we're going to assume it's pure oxygen. And we know that we are returning a Boolean, which is bool data type. So now we can go down here and test is class M. If I just provide 40, it's going to be true because we're defaulting to an oxygen atmosphere, and 40 is between 0 and 110. Is class M of 120? That should be false, and it is. Is class M 40 with an ammonia atmosphere? That is also false. So this is a great way to make your function a little bit clearer because maybe it's unclear what atmosphere expects. Granted, you should have a function docstring, but this is a nice way to look at it. We can also look at the attribute dunder, or double underscore, annotations, which shows us that takes temperature as a float, atmosphere as a string, and the return type is bool. So that's a way to programmatically get at that. Finally, let's say I wanted to declare a variable planet temperature equals 60.5. That's fine, that works. But we can also use a type hint here and say float. So maybe you've got some user adjustable parameters and you want to specify that this should be a float or this should be an int. That is a nice way to do it. So type hinting is a relatively new feature that I haven't seen around a lot yet, but it does make the actual function signatures to me look a little bit more like C and C++, which sometimes can be comforting as a developer or a user. So I hope that you found this useful, and I'll see you on next week's MetPy Monday.